Here's a question that sounds stupid until it keeps you awake at 3 a.m. You climb a mountain, you're literally moving closer to the sun. So why does it feel like someone shoved you into a cosmic freezer? Down at the beach, you're melting. Up on the peak, your fingers turn into frozen sticks. You're getting thousands of feet closer to a star that's 93 million miles away. That should mean warmer, right? Wrong. Dead wrong. And the reason why will completely rewire how you understand heat. Most people think the sun heats the air directly. That's the first mistake. Air is terrible at catching sunlight. Sunlight zips right through the atmosphere and smacks into the ground, the ocean, your neighbor's roof. Then the ground absorbs that energy and releases it back as infrared radiation. That's what actually warms the air. Think of it like this. The sun mails a package of energy. The ground unwraps it and shares it with everyone in the room. At sea level, you're wrapped in a thick blanket of warm air, heated from below. But climb a mountain, and that blanket starts unraveling. By the time you reach the top, you're holding a napkin in a blizzard. Let's do the math. Mount Everest is 5.5 miles tall. The sun is 93 million miles away. Standing on Everest gets you 0.0006% closer to the sun. That's like moving 1 inch closer to a bonfire on the other side of a football field. Functionally, useless. What matters isn't how close you are to the sun. It's what's around you and how well it holds onto heat once it arrives. And mountains? Mountains are terrible at this job. Imagine you have a balloon filled with warm air. You let it rise. As it climbs, the pressure outside drops, so the air inside expands. And as it expands, it cools. Not because it lost heat to anything, but because it used its own energy to expand. This is called adiabatic cooling. Every air molecule climbing a mountain does this. At sea level, air molecules are packed together like a crowded subway. At the summit, they're spread out like strangers in a parking lot. And when molecules are far apart, they can't share heat effectively. It's like going from a packed party to an empty warehouse. Same lighting, way less body heat. Here's another reason mountains stay cold. They're made of the wrong stuff. Rock, ice, snow, all terrible at absorbing heat. Snow reflects up to 90% of the sunlight that hits it. It's basically a giant mirror saying no thanks to warmth. Rock absorbs a little, but loses it fast once the sun sets. At night, any stored heat just vanishes into space. There's no thick atmosphere up there to trap it. Down in the valleys, the atmosphere acts like a lid on a pot, keeping warmth close. But mountain peaks? The lid is off. Heat just walks out the door. At sea level, the atmosphere is thick. There's pressure. There are molecules everywhere. There's moisture. As you climb, the blanket gets thinner. Pressure drops, molecules spread out, moisture disappears. Eventually, you're not wrapped in warmth anymore. You're just exposed. The few molecules that are left are too far apart to do anything useful with heat. Want proof this isn't theory? Go to Kilimanjaro. It's near the equator. The base is tropical. You'll sweat through your shirt by breakfast. But climb to the summit and you'll find glaciers, ice, freezing temperatures. Same sun, same continent, same day. The only thing that changed? Altitude. Commercial jets fly at 35,000 feet, higher than any mountain. Up there, the air temperature is around minus 60 degrees Fahrenheit, even in full sunlight. That's why cabins are pressurized and heated. Outside that metal tube, it's a frozen wasteland. If those systems fail, you lose consciousness in seconds. Then you freeze. Even with the sun blazing outside, because proximity means nothing without the right support system. If being close to the sun meant warmth, then space should be a tropical paradise. It's not. In space, the side facing the sun roasts. The side facing away freezes. Because there's no air, no molecules, nothing to distribute or trap that energy. So you get extremes, blistering heat and instant frostbite at the same time. Closeness doesn't matter without the systems that hold the heat. Warmth is never about just being in the sun. It's about teamwork. You need a surface to absorb sunlight. an atmosphere to trap heat, pressure to keep molecules close, moisture to store energy. At high altitudes, you lose all four. Mountains are stunning, but they're terrible at teamwork when it comes to heat. At sea level, Earth's atmosphere acts like a thermal blanket. Sunlight comes in as visible light, hits the surface, bounces back as infrared radiation. But greenhouse gases like CO2 and water vapor catch some of that heat and send it back down. That's why cities stay warm even after sunset. But in the mountains, the moment the sun dips, the cold rushes in. There's barely any greenhouse effect up there. The thermal blanket is threadbare. The Sahara can hit 100 degrees Fahrenheit during the day, but at night it plunges to 40 degrees Fahrenheit. Why? Dry air. Almost no water vapor means no insulation. Heat escapes instantly. Same principle as mountains. No moisture means fast heat loss. We live in the troposphere, the lowest layer of atmosphere. And in the troposphere, temperature decreases with height. It's called the environmental lapse rate. Roughly 3.5 degrees Fahrenheit cooler for every 1,000 feet you climb. It's a consistent pattern. Physics doesn't care about your feelings. The Andes stretch along the equator. You'd expect them to be hot year-round. At sea level, they are. But climb high enough and you'll find entire glaciers in the tropics. Latitude tells you almost nothing without altitude. Here's a wild thought experiment. What if the sun were twice as close? Earth would receive 4 times as much solar radiation. Everything would be hotter. But the rules of atmospheric physics wouldn't change. Air would still cool as it rises. So even in that hellishly hot world, mountaintops might still be cold. Just cold relative to the burning surface below. Proximity doesn't equal temperature. Context does. Look at Venus. It's closer to the sun than Earth. But it's not hot just because of that. It's hot because its atmosphere is thick with CO2, a runaway greenhouse effect. Temperatures there are hot enough to melt lead. Meanwhile, Mars is farther from the sun and has a paper-thin atmosphere. Even in direct sunlight, it's freezing because there's nothing to hold the heat. Once again, it's not about how close you are to the sun. It's about what kind of blanket your planet is wearing. The higher we climb, the colder it gets. Not because the sun loves us less, but because we've stepped beyond the shelter that makes life possible. The atmosphere that hugs us close. The oceans that cradle warmth. The forests that breathe moisture into the sky. Life doesn't thrive just because the sun shines. It thrives because of everything working together to catch that light and hold it close. So next time you're shivering on a mountain, staring at the sun and wondering why it's so cold, remember, warmth isn't about closeness, it's about connection. And maybe that's true for more than just physics. If this video made you rethink something you thought was obvious, there's plenty more where that came from. Hit subscribe.